Hello, in this video I'm going to talk about equidistribution and in this video mainly about equidistribution on finite sets. So let's start with the definition. So let S be a finite set and the sequence, let's call it Si, where it takes values in S is equidistributed in S if every subset gets its proper share. So let's formalize this. So if the set of I in 1 up to n with Si in T, so now we look at a subset T is a subset, and if the cardinality of this divided by n goes to the cardinality of T divided by the cardinality of S for all subsets of S. So asymptotically, the share of elements which are in T is the share of the elements of the sequence which are in T is the same as the share of all the elements in S which are in T. Okay, let me give a short remark, or we could also call it a lemma. This is equivalent to the following, namely the set of I in 1 up to n with Si equals to some fixed S divided by n. So the cardinality of this divided by n converges to 1 over S for all S in S. Okay, this is simple to prove. So now let's give some examples, and then after we've given the examples, let's prove some characterization. So first example is, let's say Si equal to, let's say -1 to the I, and now this is equidistributed in the set -1, 1. Or another example of equidistribution would be, let's say, let G, sorry, I want capital G be a group, and then for an element in the group which has finite order, sorry, the sequence G to the I is equidistributed. Just write in a new line. Distributed in the subgroup generated by small g. So in general, not of course in the whole group, but in the subgroup. Okay, and now having some examples also, what we're going to do next is to give some analog of the Weyl criterion. So maybe in another video we'll see the actual Weyl criterion, which is for equidistribution over modulo 1 basically. But here we're doing it for finite sets. So let P be a prime, and what we assume is that S is equal to Fp, or let's say set C mod Pc. And okay, what we want to prove is the following. Let Si be a sequence with Si in S. Let me just recall, it's C mod Pc, and then Si is equidistributed in S if and only if, and now let me be a bit more careful to write it down correctly. So we need some exponential sum, so e to the 2 pi I, then we need some parameter k, and then we need the sj. So let's do the sum from 1 to n, if and only if this is O of n, and small o of n. So if we divide by n, this should vanish asymptotically. And one more thing, this should be for all k in 1 up to p minus 1. Let me first give you the intuition, and then we'll do probably a part of the proof, and the other part of the proof will be in the next video. So for the intuition, let's have a look at the circle. So basically we identify C mod Pc with the circle, with certain points on the circle. Let's put maybe like, I don't know how many. Maybe let's put 5 or something like this. So these would be then the 5th roots of unity. And the idea is that if each of these 5 points gets its proper share, then if we add them up, they will kind of tend to cancel each other out. So they tend to the center of gravity, at least if we divide by n. And so that's why we get the small o of n. Okay, so now let's prove one of the 2 directions. So let's start with if it's equidistributed. So let's say let Si I greater than or equal to 1 be equidistributed. And then we have to have a look at the sum. So let's start simple. Let's write down the sum we want to have. We want to evaluate pi ik sj. Okay, so the first thing we do is we group by values of k times sj. So let's start with this. So let's make a double sum. Let's make a sum from, I guess, 0 to p minus 1. and we do the, let's be a bit careful. So what we do is okay, let's write down everything carefully. So what we do is we sum again from j equals 1 up to n, and we sum again e to the 2 pi I k times sj, but now maybe I should, let's see if it fits. Now we do k times sj should be equal to L. So we do this indicator function, and so this means that we count every occurrence just once. Okay, so now we can rephrase this. So we can write this as sum L equals 0 up to p minus 1, and then we do the, so we have e to the 2 pi I times L, and the other sum is just the number, so the cardinality of the set of, let's say, I is maybe not the best variable. What things do we have open? We also have some j here. Okay, let me use, okay, doesn't matter, I guess m is okay. So m in 1 up to n, where well, maybe I'll call it j, because we called it j before. So k times sj is equal to L. And now having that, so this is now our new sum, and now we will split this up, namely as follows. So we will split the sum. Let me maybe give this a name. I call this R j of n, just for now, so that we make our lives simpler. And okay, what we do now is that this is the sum L equals 0 to p minus 1, and then we have this e to the 2 pi I L times Rj of n, and now Rj of n, we expect this to be of order 1 over p, because we have equidistribution. So as we saw here, we expect this of order to be 1 of the cardinality of the set, 1 over the cardinality of the set, so 1 over p. So we do Rj of n, and minus, well, actually the fraction should be cardinality 1 over the size of the set. So let me see if we have to divide or multiply by n, something like this. So Rj of n, okay, let's do minus n over p. Okay, that should be fine. And then plus sum L equals 0 to p minus 1, and then we get n over p e to the 2 pi I L. Okay, but this second sum here is by orthogonality of characters. This sum is 0, and so we have to deal only with the first sum. So let me just write it once more. Sum L equals 0 to p minus 1 rjn minus n over p e to the 2 pi I L. But now note that this thing here isn't small O of n. This is just by definition of equidistribution, because just to show it, rjn minus n over p, and now if we divide this whole thing by n, this is rjn over n minus 1 over p, and the definition of rjn, but this shows by the definition that this has to go to 0, because this set here is up to the k, but the k just permutes the element. This is exactly what we have here in the remark. Maybe just this shouldn't have been an rj, this should have been an rl. Sorry. Okay, let's fix this. RL of n, and also here RL. There's no j, this wouldn't make any sense. Okay, so now this proves the first part. And for the converse, I'm gonna show you in the next video. So thanks for watching, have a good day, and hopefully see you next time. Bye.